Hello, dear students. Welcome to Become a Good Problem Solver event organized by the Gem Foundation. In this session, we are going to see the solution for the senior math problem published on February 2026. Problem solving is indeed an art, and all students can acquire that art of problem solving by following a systematic approach elucidated by the great mathematician George Polya. So his four-step framework has been named as UPA technique by the Jim Foundation, with the acronym standing for understand, plan, execute, and then reflect. Understanding a problem well is actually half solved, but the most difficult part that students face is not able to understand or comprehend the problem. They get stuck and then they think that problem is challenging. So, if you want to provide a framework for children to follow that can help them understand and take small baby steps towards approaching a problem, it will give them a confidence, and that's what we're going to see here. How to understand a problem? Maybe you can also underline as you read the problem important words and ask some guiding questions on what are the information given in this problem, what has been asked, is there anything that is missing, how can I find that missing thing, and during this process also draw, visualize, or rephrase so that you can understand this problem better. So visualizing is one of the very important tool for children to actually approach a problem and solve it successfully. During the process, they will also learn how to look for patterns and find relationships. Connecting the dots is indeed an important part of learning. By working on this problem, your child will actually able to gain systematic working skills. So that is a very important thing when you want to find all possible numbers, and that's what we're going to see. Let's see the problem. Use digits 1 to 5 once. Once is also important to make a 5-digit number A, B, C, D, E. Find all possible 5-digit numbers that satisfy below two rules. The two-digit number AB is divisible by 4. Okay, AB. And the two-digit number CD is divisible by 3. So here it is CD. Okay, this seems to be a bit of a number problem, right? So let's see what kind of guiding questions can help the student to work on it. These guiding questions, when they start using it, that has been already given, they also will get the skill of making their own guiding questions. List all possible two-digit numbers divisible by 4 and those divisible by 3. So because it says the two-digit number AB, which is divisible by 4, you know that numbers which is divisibility by 4 and divisibility by 3 by now. But the digits that has to be used only 1, 2, 3, 4, 5. So these are the 5 digits that you have to use. So what numbers you can get to get the numbers divisible by 4? You start from one and then check for all possibilities. This is called systematic thinking, that you have some process in your mind that you follow. So you start from one and then check further. So one, two. So maybe you can also form a kind of a list of numbers that are actually divisible by 4 and 3. So you can put this as divisible by 4 and this is divisible by 3. So now let's start. We'll start with 1, 1, 2. It's divisible by 4, yes. 1, 3, no. 1, 4, no. 1, 5, no. And then it goes on. 2, 3, no. 2, 4, yes. 2, 5, no. And 2, 1, no. So then it'll start with 3. 3, 1, no. 3, 2, yes. 3, 4, no. 3, 5, no. And then 4, 1, yes. 4, 2, no. 4, 3, no. 4, 5, no. And then comes 5, 1, no. 5, 2, yes, it is. So 5, 2, and then 5, 4, no. So these are the numbers that are divisible by 4. And let's see for 3. It is 1, 2, yes. 1, 3, no. 1, 4, no. 1, 5, yes. Now comes with 2. 2, 1, yes. 2, 3, no. 2, 4, yes. 2, 5, no. And then 3, 1, no. 3, 2, no. 3, 4, no. And 3, 5, no. But do you think that There can be anything with 3. If it has to be 3, then it should be either 3 or next to 6 or 9, right? Okay, that's a good observation. So let's start with 3. Sorry, we finished with 3. Let's start with 4. Now with 4, you get 4 1. No, 4 2. Yes. Um, and then 4 3. No, 4 4 4 5. Yes. And then comes 5 5 1. Yes. And then 5 2. Yes. No, 5 2 will not come, 5 3 will not come, 5 4 will come. So these are the numbers that can be divisible by 3. So what does the question say? Is to form a 5-digit number. Apply all the digits rule and find the combination, right? So these are the numbers divisible by 4 and 3. But what does the 5-digit number A, B, C, D, E mean? It means you can have 1, 2, 3, 4, 5. But 12,345, right? But in this number, 12, is it divisible by 4? Yes. But 34, is it divisible by 3? No. So the numbers that you are trying to make should adhere to these two rules. Now, how do you start with? You know how to list down these numbers. So just start framing the 5-digit numbers now with these rules. So we can form, let's take one of this divisible by 4 and then see what are the other combination you can get. So with 1, 2, the next two digits should not have either 1 or either 2. So you should kind of cross out all numbers which have 1 and 2. 1 or 2. So this will not come here. I think the only possibility could be 4 5 and 5 4, right? 4 5 and 5 4. So if you want to write 4 5 first, then the final digit E will be 3. Yeah. And then same with 1 2. If you want to write 5 4, the final remains 3. So this is the first two-digit numbers with starting with 12. This is called systematic working, that you start with a number and proceed the same process and then stop and then continue again. So with 24, the numbers next two digits should not have either 2 or 4. So 12 will not come, 1 5 will come. Yes. So you can put 1 5 and then the missing number is 3. Yeah. 2 1 will not come because we should not have 2 or 4. This 2 4 4 2 4 5 will not come. What about 5 1? Yes, it can come. So you'll put 2 4 5 1 and 3. Yeah. And then comes the next one, 3 2. So we'll take 32 and then we'll see which numbers will come. So it should not have either 3 or 2. 1 2 will not come, 1 5 will come. So you can put 1 5. Yeah, 1 5 and the next missing digit is only 4. And then 3 2. So we'll not have this one 2 1 2 4 will not come, 4 2 will not come, 4 5. Yes, 4 5 will come because we are writing only 3 2. So 4 5 and then the next one will be 1. So 3 2 4 5 1. And then 3 2, can we get 5 1? Okay, so 3 2 5 1 and then 4. Yeah. And then 3 2 5 4 will it come? Yes. So 5 4 1. So you have four different combinations. And then comes 5 2. So with 5 2, it should not either have 2 or 5. So 1 2 will not come, 1 5 no, 2 1 2 4, 4 2 4 5 5 1 5 4. Oh my god. So all these numbers either have 5 or have 2. So I cannot find a two-digit number without having 2 or 5. That's right, correct? So I cannot have any possibility with 5 and 2. So how many possibilities I am able to get totally? It is 1, 2, 3, 4, 5, 6, 7, 8. So total possibilities are 8 possible 5-digit numbers, and then you also know what those numbers are. So this problem is a wonderful example for, it's like a low threshold high ceiling problem where you know how you can figure out the possibilities systematically so that you will not miss any number or you do not have any number repeated. So I hope you have developed a good sense of what does systematic thinking mean and how to apply it in a simple problem like this. Keep tuned to become a good problem solver event by subscribing it from the website, and then it will be published on the 15th of every month. Keep tuned for the solution as well. Thank you.